All right, section 3, we're going to continue with our quantitative data, but again, now we're going to analyze them numerically. This is where we're going to do those mathematical operations. So a couple things, easy enough. Mean is your average, okay, and we'll represent mean a lot of time with this notation, which is x bar, okay, x, which is that little line above it. You've seen it in your calculator. Median's your middle of the highway. Make sure it's in order before you find that middle piece. Not a big deal there as well. Okay. Talk about 5-number summary. Okay, notice already that, excuse me, includes a median, your minimum value, your smallest, your maximum value, your biggest. Now, we also have what's called the lower quartile, or sometimes you'll see it as Q1, and the upper quartile, Q3. What they are, again, is your median of the lower half of your data for the lower quartile, and your upper quartile is the median for the upper half of your data. Okay, now a couple things here, just quickly. When we talk about our data sets, if my median is there, there's my lower half, there's my upper half. Okay, so if my median is actually in that set of data, okay, it's not part of either half. But when I have to go and find the middle by taking the mean of the two in the middle, okay, now it breaks it into those two halves. Should have the same number of values in each half. Okay, so in that first set, the 1, 2, 3, 4, 5, there's no way I could have 1, 2, 3 be one half and 4, 5 be the other half. Interquartile range, that's simply our upper quartile minus our lower quartile. What that does, it gives us our middle 50% of our data. Okay, because quartiles breaks it into quarters. Okay. Now, the only time we're going to use this formula is if I have the 5-number summary, and this checks for an outlier. Okay, so if what I want to do is I want to take 1.5 times that interquartile range. And if I subtract that from the lower quartile, any value in my data set that's less than that would be considered an outlier. And I do the same thing. I'm going to take 1.5 times that interquartile range, but this time I'm going to actually add it. Didn't make that change. Add it to the upper quartile. And anything larger than that value would be considered an outlier. Okay. Now, what we'll do with the 5-number summary is we're going to make what's called a box plot, okay, also known as a box and whisker. This didn't come up in section 2, but it comes up with the 5-number summary. Now, when we make that box plot, number one thing you always need to do is start with your number line, because we want to look and see how things get spread out. So I don't want to just put my 5-number summary in there, okay? Because sometimes, say, my 5-number summary looks like this: 1, 3, 7, 9, 14. Okay, and if all I do is I come and say, okay, here's 1, here's 3, here's 7, here's 9. Now they all look like they're spaced out the same. So that's why we always want to start with the number line, because we want to see that spread. So maybe I go 0, 5, 10, 15. Okay. Then what I do is put my 5 points on. Okay, so I have a point at 1, and I always do it above the number line. Okay. The 3 in the middle form our box. And so what we do is we draw vertical lines through the 3 in the middle and turn them into the box. And then what we have at the end is our whiskers that go to my min and my max from my box. Okay. So now I can see the spread a little better rather than just putting those points up there randomly. All right, next thing we talk about is variance and standard deviation. These are measures of spread. Or what we'll get into a little more is its variability. Okay. Standard deviation is probably a common term that some of us have heard. Now, how this is going to work, what we're going to do is say, here's my data set, 1, 2, 3, 4, 5. What I need to first do, if I'm going to do this by hand, is find my mean. Okay, so in this case it's 3. And then what I want to do is take each of my observations and subtract that mean. Okay, so I'm going to go through and subtract 3 from each of those values. Okay, now one of the things that I can do to check this is that sum should add up to 0. Okay, if it doesn't add up to 0, then I haven't done it correctly. Then what I do is I square all these to make them positive. Okay. And what I'm going to do again is go in here and add them up. Okay, so in this case I get 10. Okay. Now when we talk about standard deviation, we talk about kind of like the average distance points are from my mean. Okay, so we're kind of doing an average. So what I'm going to do then is divide it by the number of observations I have, and that's what's known as my variance. Okay. To go from variance to standard deviation, all I simply do is divide it, or is take the square root of it. Okay. Now, when you get to the calculator, you're going to see 2 symbols that represent standard deviation. This one, okay, is going to be sigma x. When we talk about variance, we're going to call it sigma squared x. Okay, and that's notation we'll get into later. Now, the other one is S sub x. Okay, and we'll get more in this when we start talking about samples and populations. The difference is with the S sub x, what we're doing is we're going to divide it by 1 less than my observations. Okay, so instead of 5, I'm going to divide it by 4. And I'm going to get 2.5 here. And then I'll take the square root of 2.5. This is going to be the common one that we'll use, and we're going to start using S sub x right now when we use the calculator, because that gives me my sample standard deviation. And most of what we do in stats is dealt with in terms of a sample, okay, a part of a larger group. And what this does, it becomes a larger value, which means there's more spread, allowing for the observations that I didn't get to collect because I didn't talk to everybody in my population. We'll deal with that more and more. All right, another thing, reminder, resistance to outliers. Okay. If something is resistant, okay, the outlier doesn't change it much. Okay, it'll change it a little. Okay. Not resistant changes that value significantly. Okay, so if we look at my measures of center are my mean and my median in general are the ones that we use. We usually don't use mode and statistics. So if I have my median, okay, my middle value, throwing an outlier in there isn't going to move that much. But a mean is greatly affected by an outlier. For instance, if you got a basketball player that averages 5 points a game, he scores 25, his average is going to go up a lot. Measures of spread, okay, range, interquartile range, standard deviation, and variance. Okay, now standard deviation and variance, we use the mean to calculate them. So therefore, if I use my mean, obviously that probably tells me that my standard deviation and variance are going to be affected by that. Obviously, my range will be changed a lot, because if originally I go from 0 to 10, that's a range of 10. Now if I throw in an outlier 0 to 20, now it's all the way up to 20. And so what we have here, then my interquartile range isn't going to change a whole lot though. Okay, that middle 50%. So a lot of times what we have to do is decide which measures I'm going to use if I have a certain type of distribution. This is why when we go back to section 2 and we looked at our graphs and we talked about the SUX idea, describing my distribution. Symmetric or skewed. Okay. Skewed means you probably have some outliers. Okay. So we want measures that aren't going to be affected by that outlier. So that's why if you have a skewed distribution, you're going to want to use your mean for your measure of center, or your median, I'm sorry, for your measure of center, and your IQR for your measure of spread. If I do have a symmetric distribution, we're going to use my mean for my center and standard deviation for my spread. And that's that section.